Great to see you here in this new video. We're continuing our videos about matrices, and in this video we're going to look at matrix arithmetic. Matrix arithmetic means that we're going to add and to multiply matrices. Now, the first thing, just a quick reversion. When we have the m times n matrix, we see that we have a matrix here which has m rows and n columns. And the elements in the rows and the columns are written down as Aij. I is the number of the row, while j is the number of the columns. And we can find here in this matrix, the first column has the elements a11 up to am1, and the jth column has a1j up to amj. So basically we have those m rows and n columns. Now, when we are going to add matrices, or we're going to look at the sum of the matrices, we have to consider matrices that have the same number of rows and columns. They don't have to be square matrices, but what we're going to do is to add the elements of the first matrix to the second matrix. So let's have a look here again at the same matrix, and m times n matrix, and what I see here is that I have the elements a11 I will add to b11, and I do this for the different combinations, for the different rows and for the different columns. So basically what I find when I make the sum, the first element of the sum is c11, which is the sum of a11 plus b11. And we do that for all of them. Now, this will be a lot clearer when we do a quick exercise. Here we have an exercise where we have two 3x3 square matrices. It's not a problem. We can do it with any type of matrices as long as they are the same. So m times n has to be the same for both matrices. For the first element, C11, I can say it's A11 plus B11, I being 1 and j being 1. So it's the first element in the first row and the first column, which gives us the result of 3. And when we put it there, we see 2 plus 1 is 3. We can do the same for the second element. 3 plus 3 will be 6, and so on. Now you can stop the video here and complete the calculations at your own pace, and then come back to the video and compare your result with what we have found here. So basically the formula like we use is Cij is Aij plus Bij, which means that I take the I row and the j column and we add them together. Now, this results in the matrix when we look at from the first column, 2 plus 1 is 3, 4 plus 2 is 6, minus 1 plus 3 is 2. For the second column, we have 3 plus 3 is 6, 2 plus 4 is 6, and 1 minus 1 is 0. And for the last column, we have 0 plus 2, which is 2, 2 plus 5, which is 7, and minus 2 plus 2 is 0. So you see that adding two matrices is not so difficult. It's just adding the corresponding elements. But when we look at multiplications, this becomes a little bit more complex. Now, when we have matrix operations, one of those elements is that we have to consider those different calculations, that we have to consider the different possibilities. And now we have to look at the elements that we have. So when we have a matrix which is m times n, we can only multiply it with the matrix which is n times k, whatever the last element is, and we will find a matrix which is m times k. So in this case here I considered two 3x3 matrices, so it's quite easy. And what we first do is that we take the elements of the first row and we multiply them with the elements of the first column and add them. So basically C11 is, when we look at the formula, we have A11 times B11 plus A12 times B21 and A13 times B31. Now, it's clear that for the first matrix, the number of rows has to be, or the number of columns has to be the same as the number of rows of the matrix I'm multiplying with. Now, if I have a 3 times 2 matrix multiplied with a 2 times 3 matrix, I will find a 3 times 3 matrix. But the problem is I cannot multiply B times A, or we can only have this, the commutative property, when the matrices are square. So it's very important that we see what type of matrix that we have. So we would say 2 rows times 3 columns. We can multiply with 3 rows and 2 columns. It wouldn't be a problem. Now let's have a look at the product of two matrices. It's a little bit more complicated, but we'll have this explained easily with an example. First, we have a matrix A, which is a 2 times 3 matrix, and B is a 3 times 2 matrix. So we have 2 times 3 and a 3 times 2. This complies with the rule for multiplication. So we can multiply A and B, and the final result will be a 2 times 2 matrix. The first thing to do is to calculate, for example, the first element, which is A11 times B11 plus A12 times B21 plus A13 times B31. And when we replace these numbers or these elements by the numbers from the matrices, we can say that A11 times B11 is 2 times 1, A12 times B21 is 4 times minus 3, and then A13 times B31 is minus 1 times 4. So when we add all of these, we find it 2 minus 12 minus 4 is in fact finally minus 14. And we can put this first element in the field 1, 1 of the new matrix C. So this is C11. Now, here we have the complete matrix when we calculated all the elements. So the formula here in this case for a 2 times 3 and a 3 times 2 matrix gives us AI1B1J plus AI2 plus B2J plus AI3 plus B3J. So we have in fact those different calculations to complete. We have to do that 4 times. Now, this is also a question that we can ask. Is A times B equal to B times A? Now, the first thing to say about this is when we have a matrix A being an M times N matrix and B is an R times S matrix, in order to be able to compute A times B and B times A, it is necessary that M is equal to N, is equal to R, is equal to S. It means that we can only do that when the matrices are square matrices with the same dimensions. In the case that we saw before, a 2 times 3 and a 3 times 2 matrix, we can multiply A with B, but we cannot multiply B with A because they're not compliant. Now, we can have a look, is this operation commutative or not? We consider two simple square 2 by 2 matrices. A is 2, 1, 4, and 3. B is 1, 3, 1, and 2. And when we multiply A with B, we have 2 times 1 plus 1 times 1. So you can do the calculation and you can have a look what the result is. And we can also do B times A. In case we do B times A, we have 1 times 2 plus 3 times 4. And you already see when you look at those different elements that these are not exactly the same. So when you do the calculation, please finish them, apply the rule that we did before, and let's have a look at the result. And what we see is that the matrix A times B, of course, it's a square matrix again. It's a 2 times 2 multiplied with a 2 times 2 will give us a 2 times 2 matrix. We see that the result is 3, 8, 7, and 18. Now, when we do the calculation, when we change the position of A and B, so we multiply B with A, now we see that the result is 14, 10, 10, and 7. So it is clear that the operations of multiplication of matrices is not commutative. Now, there are other rules we can apply. We can apply the rule of associative, but we only have 2 elements here. We will apply that later when we will be looking at algorithms, because we will identify there that the order in which we do calculations may have an important impact on the number of operations that we have to complete. And you will see later in algorithms, but also in normal life, it's very interesting to see that you can do a calculation faster just by selecting a different way to do the multiplications. Now, that was what I wanted to say about matrices. You will see that the matrices are in fact very important in a lot of applications. We also see, when you look at the multiplication, that there are a lot of multiplications or operations to complete. And when we want to reduce the duration of programs, it's very important to reduce the number of calculations. Matrix operations are very demanding, and you will see that there are a lot of very special algorithms written just to complete those calculations. In the next video, we will continue with the transposes of matrices and the calculation of the powers of matrices. So that was it for this video. Thank you very much, and bye-bye.